Tonight, I am directing NASA to develop a permanently manned space station and to do it within a decade.
With this order of Reagan in 1984, work began on the biggest scientific project that mankind had ever done. This order was issued by Reagan in the situation that America's rival in the Cold War, the Soviet Union, had developed the Salyut and Mir space station in space, and USA intended to build its second station after Skylab in this competition. Not the Americans knew the great thesis of this plan, and in this speech, Reagan asked for help from all American allies and other countries.
Our friends to help us meet these challenges and share in their benefits. NASA will invite other countries to participate so we can strengthen peace, build prosperity, and expand freedom for all who share our goals.
In 1985, Japan, Canada, ESA, and USA agreed to work on the space station. According to this agreement, Canada agreed to develop a mobile servicing system for the space station. ESA chose to build an attached pressurized module for the program, and according to this agreement, Japan also agreed to provide an experiment module. NASA's initial estimate for the construction of the space station was $7 billion, which was 71.4% of the cost of America's share. Japan and ESA had to pay 12.8% of the cost, and Canada's share was 3%. But the initial cost of this super scientific project increased more than twice and reached $15 billion. The construction of this mega scientific project had a lot of costs, and for this reason, the American Congress came in several times to reduce the budget. As the work progressed, the cost continued to increase, and contrary to the expectations of NASA managers, the injection of money into the project was not much. On January 28, 1986, with the Challenger explosion disaster and the deaths of 7 prominent NASA experts, the financial and spiritual cost to NASA increased again. In the meantime, a global political event affected this super scientific project. The collapse of the Soviet Union in 1991 and the end of the Cold War became a turning point for this super project. The Soviet Union had the experience of carrying out very large space projects, and on the other hand, the presence of Russians in the project could slightly reduce the financial cost of the project for the American side. In the summer of 1993, with the agreement of the American and Russian governments, the construction of the project, which we call the International Space Station, started officially, with the completion of the two Mir 2 projects and freedom. But this was the second phase of the war. The first phase in 1992, with the agreement of Yeltsin and Bush, the Mir shuttle program was implemented, which was an effective step in the pre-construction of the space station. American space shuttles connected to Mir space station 12 times between 1994 and 1998. The International Space Station was officially born on November 20, 1998, with the launch of Zarya by Proton rocket from the Kazakhstan station. Zarya was responsible for providing electrical power, warehouse space, propulsion, and navigation during the initial stage of assembly. 2 weeks after the launch of Zarya, the first American part of the station, called Unity, was launched by STS-88. One of the most complicated missions of the scientists started after the shutting, and that was to connect Unity to the part of Zarya. It took 3 days to complete this mission, and finally Unity was successfully added to Zarya in space. A year and a half after the connection of the Unity section, Zvezda was launched into space by the Proton rocket, and by connection it to previous 2 sections, it became possible for 3 astronauts to live, work, and research in the station. In 2001, an important part was added to the space station with the Canadarm2 connection. which was the result of 15 years of complex engineering work from design, construction, testing by MD company and cost more than $110 million. Another part that was built by the Canadian was the Dexter part, which was built at a cost of $200 million and placed on the space station. By placing these two on the station, it was possible to install different parts on the station without the need for Canadarm connected to STS. In 2001, the United States added another part of the station called Quest Airlock to the structure by STS-104. By adding it, the possibility of a spacewalk for astronauts was created. In 2007, the USA added the Harmony Node 2, which is now the station instrument center and includes 4 racks to the space station. The European Space Agency was also not idle during this period, and finally in 2008, with the launch of Columbus into space, it officially formed a part of the space station. This part was considered kind of a space laboratory, which made the total cost of the European Space Agency in this project reach $8 billion. In the same year, Japan completed its respective part by completing Kibo, which includes 6 components named PM, ELMS, PS, RMS, EF, ELM, ES, and ICS. Designing and manufacturing Kibo requires a strong technical and industrial knowledge. It was the Japanese who did it that we see the technology and skills needed to develop Kibo. With the completion of the ISS, its dimensions have reached the size of a football field, and 5 space agencies of Japan, America, Russia, Canada, and Europe participated in its construction. The construction of the space station has cost $150 billion so far, which is the most expensive scientific project in the history of mankind. Out of this $150 billion, $94 billion was spent by the United States, and the share of the European Union was $8 billion. Designing and building a space station is one of the most complex scientific projects that mankind has ever done. Hundreds of scientists from different nationalities participated in this project. This project is one of the honors of humanity, and it represents an international cooperation that can carry the message that the unity of all countries in order to carry out peaceful scientific projects can be useful and efficient.